In our next video, let's skip to the problems that are uncommon. So we have a set of 16 mm diameter bolts having hexagonal heads 24 mm wide across the flat sides. And it is used in a beam splice end plate with standard bolt holes with diameter equal to the bolt diameter plus 2 mm. The maximum bolt tensile force is 30 kN. And we are to find the maximum bearing stress on the splice end plate. Now, ito yung figure natin. We have a plate, and then merong hole dyan sa gitna, and then meron tayong hexagonal heads, which is ito. Now, we are to find the maximum bearing stress on the splice end plate. And so, we are essentially looking for the contact stress or the bearing stress at this part. Now, alam natin na itong bolt is punched through the plate. And so, itong area na to, we have to subtract this one. Kasi yung subjected to bearing is only itong area na to, minus itong hole sa gitna. Now that we have made that clear, let's draw a hexagon. Magiging ganito yung hexagon. And so, ito na yan. Now, let's expand this. And then, let's connect these so that it will be easy to solve for the area. Now, dito sa gitna, merong circle. Ito yung top view ng cross-section ng bolt. Now, we need to subtract this area sa hexagon natin. And so now, the hexagonal heads are 24 mm wide across the flat sides. And so that will be this distance. So this will be 24. And then this will be half ng 24, which is 12. Now, in order to solve for the area of the hexagon, let's just reduce the problem into the area of one triangle multiplied by 6. Because meron tayong 6 triangles. And so now, let's try to compute for the area of one triangle. Now, let's project a line dito. These are all equilateral triangles. And so, this angle will be 60 degrees. And then, this distance is equal to 12. And so, let's label this as x. Now, in order to solve for x, we need to use the tangent relation of these sides. And so, tangent of 60 is equal to opposite over adjacent. The opposite side is itong 12. That's opposite to this angle. And then over the adjacent side is x. And so now we can solve for x. X is equal to 12 divided by tan 60, which is 4 square root of 3. And then let's just store this value dito sa a, so that we won't need to type this. Kasi it's very important to save time in your calculations. So we stored this sa A. Now we need to compute for the area of this whole hexagon. Now that's equal to 6 triangles. And then the area of one triangle is 1/2 times base, which is 2x, times height, which is 12. Now, this x value is stored dito sa A. Ito yung area ng triangle. Now, this is still the area of the hexagon. We still need to subtract itong circular area. Kasi hindi yan subjected to bearing. Yung subjected to bearing is only this one. Kasi itong yellow na area, yan yung merong contact stress dito. Kasi itong naka-yellow na area, that's in contact with the plate. Now, sir, what is this area? The area of the circle is the area of the bolt hole. Now, the bolt hole is the diameter of the bolt plus 2 mm. The diameter of the bolt is 16 mm. And so the diameter of the hole is equal to 16 mm plus 2 mm. And so that will be 18. Now, yung reason kung bakit may plus 2 yan is because we are applying an allowance. Because we can't insert the bolt threads kung wala yan. And we know that the bearing stress is equal to force over area. And this area is the contact area. Now, the force is equal to this one. Let's just label this as P. And so our force is 30 kN over the contact area. Now, the contact area is the area of the hexagon minus the area of the bolt hole. Now, the area of the hexagon is this area minus the diameter of the bolt hole is 18 mm. And so, this area will be pi d squared over 4, or pi times 18 squared divided by 4. And that's equal to 6 times 1/2 times 2 times itong x nakastore dito sa A. And then times 12. And then minus pi times 18 squared divided by 4. And so that will be 244.36. And so let's just write this dito. And then let's plug this value for A. And so this will be 244.36 mm squared. But our question requires the bearing stress in MPa. And so let's convert Kn into N. Now, 1 Kn is equal to 1000 N. And so let's input this in our calculators. And so this will be our answer, 122.77. Now sir, what if I did not use 18? What if I used the diameter of the bolt? That will still come out in the choices. Let's try to check. If we used 16 instead of 18, let's type that here. Let's change this into 16. And then over 4. Now that will be equal to 100.75. Now this is in the choices. And so that's why you have to be careful whenever you are solving for these types of problems. Because the wrong answer will still be in the choices. And if you were careless, you might have chosen this one instead of the correct answer.